Okay, for 1341, I'm going to kind of look at this geometry for a minute. The nut, kind of a specialty nut, looks like a jam nut. I think we'll probably be able to find one of those in the toolbox. Looking at the threads, it is called out as a 1.5 6. So we're getting into a pretty good sized piece. So we'll have to check the hole wizard and the annotations for that size. So pretty much like the 1340 model, again, you're picking one of these two to do for the assignment. We're going to do the first one as an annotation. Since we have a couple of threads, we'll try one internal, external as the swept cut or with the threads. But I think that the graphics card was already struggling enough with those, so we'll get a sense of what they can do. And then I think geometry is pretty straightforward, only a couple of tight tolerances. So let's start again with the base. We'll identify the hardware. See, saw that there was a keyway. So 0.25 by 0.5 slot, but then it didn't really set screw with bushing in place. Now, apparently, oh, they're going to install that at the same time. I don't know as far as a strategy that that's really great. We can take a look at it as far as an assembly feature. It will be one of those. I put a question mark on that. So 2-inch 4.5 threads on the ends, and left-hand threads. Okay, so that means they're going to turn opposite each other. Let's see, just want to double check. UNC to be through. Oh, they're calling those out left hand both ends. Huh. All right, that means that they're going to turn opposite of each other. So we do have to identify those left hand threads as a specialty item. All right, well, that is definitely going to be interesting. So I'll fly that out of the way. We'll start with the lower piece. And we are still in an inch part. All right, so with the spherical end, I just noticed that, I don't know. I was going to say we could build this up with the spherical end. It might be an advantage to go ahead and see what it does with the annotation and go ahead and make it a revolve. So its orientation is kind of on its side, so if we drew it in the front plane, it'd be a little different. We'll go center line, infinite length, horizontal, set it on the origin, and our distance is 7.25, so again, these are pretty good size pieces. We have the step. All right, and then if this, well, since it called out spherical, it's going to be full. So I went with the continuous tangent arc from the endpoint out, and then I'm just going to switch that back over. And a lot of times I leave this line in and change it over to construction line, because if this doesn't work out or it doesn't do what I expect it to do, I can always go back and change from construction to object lines, alternate, and just have the base and go about this some other way. All right, so if I pick just the object, since I chose that as my strategy, I'm going to have to go from the end line to the top of the sphere, 7.25. and missed the 7. All right, try that again. 7.25. The outside diameter 1997 to 1999. We will go with maximum material condition 1.999. The base, well, this piece is going to be 4.75, so since I'm in a diameter, I'm going to go ahead and hit escape. That will return me to the linear. And then we have also a limit dimension, and that time I picked the object. I did not get the center line, so I'm going to switch back over to the center line so I get the diameter. And 1.748 to 1.749, maximum material condition. So, since that didn't build out, let's see what we have for coincident. No equals. I'm going to go ahead over to other and make that dimension driven. And we'll try and figure out what I told it to do or what it didn't like. All right, so we're losing a little bit of our tangency, or at least it becoming spherical. It's going more to a point. So this would be one of those instances that I take the center point and I can try. I'm going to go ahead and control select the end point and then merge those points. All right, so now I'm going to go back and we'll see if we can undrive it or make it a driving dimension again. 1.7749. All right, so that adjusts then. So I don't know if I entered the wrong value or if it just was a little strange. So, all right, for the tolerances then, let's go ahead and include our limit dimension, and it is minus 0.001, and accept. And then I want to mark for drawing. And again, just off of the screen, right-clicking, marking for the drawing, limit dimension, and mark for drawing. All right, so that gives me the geometry. And let's see, don't know if I'm going to be able to bring that one up a little bit. Let's see if we can zoom up on it a little bit. So I called it out as spherical, but now I'm not so sure that it's a full sphere. So 0.187, oh, I thought that was 0.87, so 3/16 on the spherical. So maybe we didn't want that to go full tangent. All right, so the correction here will be to escape out of the dimension, and then there is the tangency. So that being the case, I should be able to take this object line and go 187. And it picked up as a driven dimension. So let's see what else is, oh, the center mark as the piece. We got a coincident. Let's see if we can take that off coincident. No. All right, so that being the case, all right, still on center. It didn't like my my number. I could draw the center line back in, but I don't really have to. I go from the end point to the point, and then as long as I make sure that I get a linear distance, set it to 1.187. All right, so it wasn't a full sphere. I missed that dimension. Basically, when it comes through the fork, they want it to be able to align. All right, features, revolve. It has the one center line. If I left the other center line, then I would have had to have picked. So not necessarily a bad thing that that one went away. All right, into the annotations. So I added this last time. If we want to add a tool, I'll make sure that I'll try to make sure that I covered everything that I did in the previous video. I go commands, annotations, and then we drag for the cosmetic thread out to. I can just click on it and drag it out. And when I drop it, it will be added to the command manager. If you don't, then it is available under Insert, Annotations, and just off screen we're looking for Cosmetic Thread. Alright, so it thinks it found a 1 1/4. So there is a 1 1/2 6. And that is what we're looking for. So I know I'm pretty close to the screen, but the pull down, we get the 1 1/2 6. And then the up to next, no, it'll be a blind in condition. And from the end, 1.25. So it looks like it's going to be about 1 inch and 60 thousandths. So let's go 1062. All right, so it picks up. And it only needs to be enough to engage the nut and then go through the backside of the fork. All right, so we're going to start a new project or a new. Oh, I did that as an assignment 8. Probably need to gather all of those up and put them in their own folder. So I'm going to make a new folder, 1341. No. Oh, I clicked out of it. All right, so 1341. And then it picked up the base, which was not. We need to make this a number 4 pin. And then we'll save. All right, what did I miss? There was a 0.25 diameter hole and a dowel pin on the back side. So, and that was 7/16 deep. All right, so in the last video, we made a couple of planes. So this plane, I'm going to go to the top view and then Control select the cylinder. We're going up to the reference geometry, picking a plane. So this is going to be, right now it's showing as perpendicular. It defaults to perpendicular. We are tangent to the cylinder, parallel to the top plane. And that gives me a location that I can open up the hole wizard on. All right, so if I hit the S key, we're looking for the hole wizard. If I hit the S key, I'll find the hole wizard icon. And then we have a hole. Fancy inch, fractional sizes are 1/4 of an inch. And just jump past it. There we go. And then I can always show the decimal values if I need. And then the depth to the shoulder, 0.438 or 7/16. I'm not putting any countersinks on. We'll look at it in relation to the origin, so that little bit of inference will help me. Even if I don't get it to be horizontal or coincident, I can always come back and add it. So horizontal, and then we're 375 off of the end. Gives me a position. Now we go ahead and accept. All right, so I would rather see you do that. You can try the 3D sketch. It is not impossible to put that geometry in with the 3D sketch. I think it's a little more difficult. All right, so the dowel pin then is going to be in our toolbox. And so we need to come up with a strategy for laying this out. Since the ends are not tangent, they're a little bit bigger than the body. I'm looking at it coming down this face and then making that curve. I think I could still go ahead and build this shape out in, so 7.5 inch wide, 4 inches tall, that we could build those shapes out and then after the fact add in the bosses for the fork. So we're going to try that, see how far it gets. Make sure to save. And then I'll go ahead and close that one. File new. And we're still on the part inch. So on the front plane, we'll open up a sketch. Alright, and I'm thinking that this is going to be something that I can mirror, so vertical. Whenever I get mirror symmetry, I'm going to establish the center line. Thinking where a convenient spot for the origin would be, I'm not so sure that I want it through the bosses, or that I have to have it to go through the bosses where the pin aligns. We'll go ahead and try it on the base. So come over, and then the bosses are going to build out a little bit, so we'll just come down probably to center line, our calculation, and then tangent up to the point. No, that is interesting that it comes back to that. So okay, so at the top, I'm looking at a diameter of 4 inches, but then as this arcs down, it ramps, or it angles back into the thickness of the boss. So let's go ahead and take a look at that geometry, because this is not quite going to blend the way that I'm expecting it to. So tangency, probably not. One of the things we could do is a split entities. I could just go ahead and delete the line and redraw it. If I go into the tools and the sketch tools, I can find split entities, or I added it in a previous video to my heads up display as an example. And when I split this entity, it's going to allow me to make that separate. And then I need to take off the collinear. And then I believe it's still going to want to stay tangent. It doesn't look like it's that much of an arc, but, well, we'll go ahead and see what we get. So 4 inches to, that's across the face. On the ID, 3.5 on the OD. Right, and then I was looking for the, from the top to the center line of the boss is 11 inches. So let's start with that one. Let's see, the radius is 5.5. The outside dimension, 6.062. Right, so we're going to set some symmetrical anyway, so we'll go ahead and start picking those. All right, so it's staying in the diameter, the inside 3.062. We had a size of 4 inches over the top. Okay, and then I'm going to reverse, bring that one out, and also had a diameter of 4 inches. So we'll go back to the center line and 4 inches. Radius then we had for 5.5. Getting the geometry in, and if that comes down and blends directly into the boss, then this would be, go ahead and escape, get back into the linear. This should be 1.75. Alright, so now the question is, where and how does that blend? Showing it as 7.5. So with 7.5 on the overall, we're going to set, accept, go into the leaders, tell it that it's a max. That doesn't look right for a max. Let's try that again. See what the min looks like. Alright, so the min is going from where it'll be arc to arc, and we're pretty close to our number, so 7.5. Alright, so then the interior, this ends up being 1.5 inches. Alright, so coming down to the blend at 1 inch. Okay, so pretty much the same center line. We'll just have to see where that blends. So the mid would be 1 or 3/4 of an inch. I'm going to come up so far, and then again with the tangent, bring it back, and that is going to be a radius of 1.25. And the assumption, so let's see, it was 4 inches over the top where it blends. And then this is going to terminate into the cylinder, so I'm kind of thinking I'm going to need that cylinder pretty quick. On the base, so let's go ahead and fly that back in. So 3/4 inch step on the 4 inch diameter, and then down here is a diameter of 3.75. Fly that out a little bit more. Alright, so I'm going to go ahead with Alright, and this is one of those cases with the contours and regions that I think a little extra, probably more than I need, is going to be better than not enough. So 0.75, just because the contours are getting a little wild. Alright, so 3.75. Oh, and then the inside step had a 1/4 inch radius past that point, so it probably does come up and blend out at that point. Okay, so the 3.062. Okay, so I'm going to overlap, and then we'll go up. Alright, so I've already made this more complicated than it needs to be. Alright, so a 1/4 inch radius inset. So I'm just trying to get the visual clues as to what I want this to do. Oh, and it was became driven because it went coincident. And then now that is a driven, so I need to make it driving. I change it over to where I can make the dimension. The 1.75 will make even, so that can be coincident. And then bring that back up. And we'll just connect the dots so that I can try and clean that out. Alright, so this one came up to this point. So the 3.75, but this is falling away on an arc. So let's go ahead and put in our dimension of 1 inch. And then we'll build that out. Alright, so 1/4 inch on that one. I hope that math works out. So the 1 inch would actually be from here to here, and then 1.5 overall. Alright, so 1 inch. So I think what that is achieve the same thing as putting the vertical lines. And then a radius of 1.25. Now let's zoom up on it a little bit more. Maybe 1.125. Looks like they slid an 1/8 of an inch in there. Alright, so again, we've got to figure out a location. Since they did 0.75, I'm not seeing anything on the cross section. 3 inches on the depth. That one is the base. So we're looking through the keyway, got the little notch. Would like to know where that is terminating at, if that one stays parallel or starts at that point, or if the 1 inch is going to stay consistent all the way up through the bend. And then what are the radiuses? Does it call out? Radius of 1/4 inch, radius of 1/8 of an inch, so probably on the interior. So yeah, it looks like the 1 inch is going to stay consistent all the way up and over. So that being the case, oh, I'm still in the dimension. I was trying to pick it and move it, and I wondered why it was giving me a dimension. Alright, so between the two, that should come back coincident. And now it's going to need to be a little bit more, so probably at least vertical to its own line. So since that's a blend, I'm going to go ahead and leave it. Wow, that turned out a little more complicated than I would have liked. But let's go ahead and mirror it and see what we get. Okay. So steps and blends. Alright, so if I grab these geometries, we're going to go Features, Extrude Boss Base. Looks like the only taper was that outside, so Contours and Regions. And yeah, we'll go ahead and include. Alright, so not easy to see, but I think that gets it. So the first round here is going to be a feature that is mid-plane, and we'll have 1 1/4 inches. Alright, going back into that sketch, I want to share the geometry, so extrude. Now we're going to be on the inside, so that contour and that contour, and we'll have to see what this looks like. Alright, so mid-plane, and we're going to end up at 3 inches on the overall. Okay, so that blends in okay. So maybe a little weird through that segment, so let's go ahead with the sketch. And if I wanted to tie to that geometry, we set the diameter at 3.75. So if I go back and show that sketch, I should be able to right-click on Sketch 1, and then hit the eyeball to show. All right, and then I believe that was the 3.75, so that makes sense, 1.875. And selecting the circle, we'll try for a coincident. All right, that causes it to go fully defined. And it doesn't look like the arc quite did what I expected it to, but let's go ahead and extrude. And we're going to go up to vertex, since I have that sketch geometry to work from. And that is looking really close, but I think I missed it by that much. Alright, so as that blends in, we need just a little bit more, even though it doesn't overcome it. So let's go ahead back into the original sketch. So right-clicking, waiting for it to come up, let's edit the feature. So I think for this, we'll go ahead and connect those, so that they can span all the way across and include. And then it's not entirely unexpected Interesting that it took that segment out. So up to vertex. So I don't think there's anything wrong with that one. Let's go back into the Boss Extrude 2. And we want to add one more region. So I'm going to make sure I'm selected in the region. Okay, 2 more regions. And interesting that it tried to make that a cut. Oh, because I opened that up, then I do need to add it to this one as well. And it's not going to completely, if it's not going to completely close in. All right, so that gives me some geometry that also closes the gaps. That was a little scary, but we'll see what we get. All right, so the other sketch then is going to go out to 4 inches. Make sure that I pick my circle. And we're going to bring it out coincident to the outside. Go coincident. And then features, extrude, up to surface. And we'll pick that surface. And that'll give it kind of the outside ring. Alright, so they don't show it as a blend, but we have to come up with some strategy to deal with those rounds. So I think I'm happy with a little bit of step moving out, and we have most of the shape. So the effort went into creating the sketch and trying to get the visual. Now that we have the geometry, we can do a little more with it. Alright, so the one thing that is a consideration here that I didn't pick up on is I'm going to leave the corners right there, so I don't believe I want those corners to be in the sketch because they're going to interfere with the boss. So that being the case, let's see how much trouble I get into by closing those off and making them an unselected area. Alright, so that brings it down flush, and then I can continue with generating those boss features. Alright, so the boss, and what I'm referring to is these lower segments, 4 inches on the inside, 3.5 inches on the outside. So probably need to start with the 4 inches. And the 375. All right, so I would like to go ahead with the sketch. And we'll find the center. We'll go up a little bit more. I did not put anything in the sketch to represent the 4 inches, so there's the 4. We'll zoom out a little bit, zoom in, and then bring it. So between the two, that is 1.5 inches, the 1/4 inch on the inside. So this is going to extrude out. And we need to reverse the direction. Instead of extrude out, but it's going to go 1.25 on the inside. And then we're going to come back on the same face and sketch the 3.5. Okay, adding the dimension. Bring it back to center. See if it'll pick up center. All right, we got one of them. Okay, we got a snap. There it goes. All right, and then the features, since I included that, I'm going to extrude, and we'll drive it with the sketch by going up to vertex or up to surface. All right, so interesting little blend there that doesn't come quite down tangentially unless there's taper in this direction and that direction. All right, having done that, I really don't want to recreate all of that geometry. It wouldn't be too bad, 2 features. But let's go ahead with the mirror. And I'm pretty sure that I'm through with the sketch. We may have to come back to it, but I'm going to right click and hide. That'll kind of clean up the geometry. And then boss 5 and 6 and the right plane. So I'm looking for a plane that bisects the part. And then up under the linear pattern, the down arrow is going to let me mirror. And we're mirroring the features so that we end up with that same geometry. Alright, so we'll double check by selecting the inside faces, 3.062, that adds up, and 6.062 gives me the geometry. Alright, so that was way too much fun. I'm going to go ahead and save, and this is going to be item number 1 and the fork. Alright, so that doesn't look too bad. Then for our geometry, let's go ahead and we'll put in the 1.75. Alright, so maximum material condition, this is a 175 to 1751. So 175 would be the maximum material. We're going to go limit, and it is a +1 dimension. Alright, so when we look at the pin that goes through here, and I'm just going to go ahead and rotate around, features, extruded cut, and then we'll just go up to next. All right, through all would go all the way through the part, and even though the other side is 2-inch, I really don't want it to go all the way through the part. So there is a pin location we'll have to come back to. So detail A, and then a chip slot for the dowel. So apparently that is on the back side. Just got the wrong one in there. So the chip slot for the dowel on the back side. 4375, since the dowel is on that end, it's pretty much going to have to come through. So we're going to be on the far side. So we'll go ahead and include it here. All right, and then we're into the circle. Going to hover over that edge until we find the center point. We have 2-inch to 2-inch O2. And so 2-inch will be our maximum material condition, extrude cut, and up to next. Okay, so we got those in there. I don't think that I marked either one for drawing. So I don't want to rename it. We do want to mark it for the drawing. So right click. And oh, I didn't set that one for a limit. All right, so limit, and this is going to be a 0.02. And then one more double click, right click on the dimension, mark for drawing. Okay, so that includes it. All right, so we have that slightly bigger size. So before I put the fillets on, which we have, well, we do have that slot thing. All right, so I'm thinking, yeah, it's going to be an end mill. They don't specifically, now they kind of show it as a flat. I'm thinking it's going to truly be a knob round. So, you know, at that point, I'm just going to go ahead, and center is easy enough using the knob round tool. Said that it was going to be 5/16 wide. 312. And from the intersection, well, I don't really have an intersection to the end, and really can't make it to the end if this is a dowel pin and it needs to be 4375. Let's go ahead and accept. And then the leaders, we're going to go from a min condition to that stop. And we'll have a little extra for 437. Okay, and then the depth that we're given is also 0.312, so extrude cut 0.312. All right, so I'm not sure how they would make that. It's too narrow to be a broach. So I'm going to go ahead and make the assumption I get to make the choice on the designer, that I'm going to do what I need to get that dowel pin to seat in there. All right, and then last we'll try the hole wizard. So S key or up on the command manager, hole wizard. We're going to have a tapped hole, and then we'll scroll down, go all the way to the bottom, and we have a 2" by 4.5", which just happens to be the one we need. Its in condition will be up to next, and then the position will be at the center of the boss. I'll go ahead and hit accept. So with the hole wizard, we automatically get the cosmetic threads, and we have the geometry. All right, so one more save. All right, so there are some 0.25 radiuses that we'd like to go ahead and get out of the way. And I know that I saw at least the outside here. And between the blend and then coming around the outside. Okay, and rotating over. Let's just start with those and see what we get. All right, and then radius 0.25. And we'll see what that does. So it couldn't calculate, and this is fairly complex in here, so we'll let the feature expert take a stab at it. And I'm going to look at the dimensions while it's doing that. All right, so the 0.25 to the outside, that's probably the one that's creating the issue. If I just stayed to the outside, that should have been fine. Radius of 0.25 is on the interior, 0.125 on the exteriors. So I'm thinking probably all of the interior 0.25, all the exteriors, yeah, 1.25. All right, so put the blend in there. That didn't turn out too bad. That one's a little strange. All right, let's see what we can get for interiors. And the problem with these cast pieces is that the patterns were pretty much whatever was convenient and could be made. So pretty much a blend to suit. All right, so fillet of 0.25. See if we can get one without the fillet expert. Nope, not yet. Or the feature expert. And again, where we have those multiple points coming together, that's not exactly a surprise. So we're going to end up with a pretty decent little stack of fillets here. All right, so I'm going to go ahead and bring that one around. Okay, oh, we had the 0.25. All right, so that's an interesting blend. All right, let's see how it goes. To the outside. And then our outside. And then we'll pick to the outside. And two more on the interior. All right, and if there is another one underneath, then we'll pick it up here in a second. Alright, so that one blended. Kind of strange, but they are working. Alright, and then I think we had 3.75 and to 4 inch, so I should be able to sneak another 1/8 inch fillet underneath. And so 1.25. Alright. Oh, and then there was the last. Alright, so let's just see if we can. Let's see, that was the last of the 0.25s. I'm just going to right click and edit, come back and pick up those points and see if they'll go into the mix. Okay. And then actually, with that being an outside, let's see, which fillet was that? Fillet 10, so that one was an 1/8 inch since we're kind of in that area. And maybe we'll just see if I can add it to the last one. Alright, so we have tangencies. It's going to find those areas, find those blends. And aside from the fillets being pretty wild, I think we have it. Okay, another quick check of our geometry, and that took longer than I kind of expected it to. Alright, when we get over to the assembly, we'll double check our numbers, but that's pretty much the piece. Alright, so the left-handed threads. And that's the strange. If they call that out as tie rod, left-handed thread both ends. For this to be opposite rotation, that if you turn one, it doesn't turn the other. This really should be right hand, and then this would be left hand. So that one's called out as left hand. All right, so I think that's a mistake. We're going to see what we have for left-handed threads to begin with. So we save that one, and this may be one that we go ahead and we cut the threads. So we're still in inch, and I'm thinking top plane. I draw the circle. Also, with this geometry, the previous video I started bringing items into the assembly right away. I don't know, maybe just because of the fork being a little more complex, that I'm waiting and going to bring this one in one at a time and get them lined up. So with our 2-inch 4.5 threads, they have a 2-inch major diameter. And we could go mid-plane. The overall is 6.2 inches. No, it's got to be more than that because now that looks like 62 inches. Wow. No wonder they did a section cut. All right, let's see what it looks like. It's a pretty good sized piece, so that will definitely be interesting. And the chamfers on the ends are 1/4 inch. I'm going to go ahead and include those before I start tackling the annotation. All right. So a cosmetic thread. And when we're looking at the machine threads, I really don't have a mechanism here to tell it that it's left or right hand threads. So let's go over to, we'll pick the lower edge, go into the thread, and this one we'll pick up. Let's go ahead and build in the offset. Quarter of an inch should be plenty, which was what the chamfer was. We're going to reverse the offset to the outside. The thread length 3.875 on this end, and so we're going to be at 2.5 or 2 inch by 4.5, so 0.22222. Nice. And then the end condition, there we go, 3.875. And then we'll go ahead and accept it. Alright, so this is the tie rod. Right, zooming back up in on the other end. Hole wizard. Okay, we'll go with the thread. Alright, should have the same types of numbers. 3 inch. We're going to have the 1/4 inch offset. Make sure it offsets to the outside, so it fully cuts. And then, I know we saw it earlier. Maybe that was on the trim within face. Well, we'd pick the face on that one. I'm just offsetting it to get the same result. Alright, so on this one, maintain thread length. Inch die, inch tap, metric die. So this one, we're not getting the left-hand thread either. Oh, there it is. Thread options, left-hand thread. So we'll go ahead and reverse it. Okay, so we're going to save that. That is item 3 of the tie rod. And we'll save. All right. The bronze bushing, that one shouldn't be too difficult. So we have 3 inch 01. This is going to be a press fit, so 301 to 3 inch. So it'd be pretty much a light interference fit all the way to a 2000s press. Basically taking the largest number to the smallest number. So we have the they're calling that a graphite bronze. Well, it's going to be phosphorus bronze because I know we have that one. Alright, so on the right plane, new, hard inch. And because whatever is going to go through there is also a fairly tight tolerance, let's go to the right plane, open up the sketch. Draw the 2 circles. Alright, maximum material condition of the exterior, 3.002. Limit dimension has a minus of 0.001. And then we're going to come over and mark for the drawing. So right click, come down to mark for drawing. Back into the dimension. Okay, we'll let it catch up. Since I'm right here, we'll go smart dimension. Okay, so I got something turned off because we used to, whatever was selected went ahead into the dimension, or for 2018 they decided that we don't need to do that anymore. So maximum material condition of the hole will be 1.996, and then the limit dimension is a +2. And we're going to come over, right click, and Let's go into select, move it up here, and manage to jump over to the 3, mark for drawing. Alright, so said we're going to try the set screw. Holds, let's see, headless set screw with bushing in place. We're going to try that as an assembly feature. So extrude, and then we'll go mid-plane, 3.218. Go ahead and save. Oh, that one's saved as part 10. Alright, so this gives us the opportunity to do a quick rename. Alright, so right now we're not in the I haven't saved yet, so I was going to say we would go into File Explorer and be able to rename, but let's go ahead and this is number 6, the bushing. I didn't think I'd seen that save as pop up. Alright, so new part, and for the head, the drop forge, keeping that spherical, I think that one will work. Alright, so 3.625 on the outside. We're going to do this as a revolve. It has the interior geometry for the left-hand thread. So if we go ahead and include that shape, then we should be pretty close to the geometry. I don't believe the thread opens up the hole, but we'll give it a try. Alright, so spherical 4.875, and then center distance of 4.5 or 5.5. Alright, so front plane, sketch. Because we're revolving, we will go center line, infinite length. Hitting L on the keyboard to get in the line. I'm not going to include the whole location. And then we'll be up, over, back, through. And then with the radius, let's see, I don't know that that's going to be tangent. Now let's go ahead and put the dimensions on it since I'm not sure. Go ahead to center line, 3.625. And then to the inner diameter, 3.375. Alright, and then the height of 0.625. Okay, we'll go ahead and accept that. And then, well, given that we're going to have the sphere at the center line, we're going to go with the center circle. And then that's going to come back up to the intersection. We're going to have a radius. So that looks sort of close. Not great, but close. We'll switch back over and see if it pulls it up. Leader. Oh, I need to switch from radius to diameter. I was looking for my end condition. Alright, so 4.875. And then from the center to the base, make sure I'm in the dimension, center to the base to the center, 5.5. All right, I think that will pretty much do it without the fillets. So revolve. All right, so I forgot to connect the dots, so it's asking me. I want to close that off, so it's going to draw a line from the origin to the end point of the arc and close that region off for me. All right, so then as far as cutting the outside flats, they want a 3.75, so we're back into the front plane. And I'm just going to go ahead and generate 2. And let's see if we can find that silhouette edge. Okay, so coincident, that'll work. And maybe I'll mirror this center line vertical, and we'll go ahead and keep it infinite length. All right, so that one's moving along. We'll give it 3.75. Interesting, that comes up just inside. So maybe that wasn't calculated out. So 3.218, no? So that's the same size as the bushing, the 3.218. And then sure enough, they gave it a 3.375. So I would consider in that case going ahead and making that 3. Not even going into the blends. If we brought it up, we're talking 160 thousandths or so. Yeah, I would consider making this a little bit smaller since we have the length. All right, and then the outside, seeing that silhouette, but it's escaping me. And then we're going to go tangent. From right to left, window pick and mirror. And then the features are going to be to extrude cut and through all both. All right, so it's that little notch that I don't like in this this design. So back into the revolve, double click. Let's see, that was all dimension. The 3.625 was on the outside, 3.375. Let's go to the 3.218. And at least see if we can make that step. All right, so since that didn't calculate out quite right, I don't know, the 3.75 isn't working out at the 3.218, 3.115 on my normal distance. So one of those has to have priority here. So I'm going to stay with the 218. So that being the case, let's leave that for reference, and I'm going to go to the other on that dimension and make it driven. And since we already set and reduced the boss, 3.218 brings it out to the side. Oh, I guess if I'd paid attention to what I told it, 3.662. Yep, 3.662. That brings it up to the flats. All right, and then the hole. So this one is a limit dimension. Maximum material condition is 3 inches. And it did not quite find the center, so let's drag away. We'll locate, bring it back to that center mark. Well, in that case, we're going to select Control Select. Selected the edge, told it to select the center, and then Features, Extrude Cut, and Through All. All right, so what I didn't include on that one is we're going to come over to the limit, and it is going to be a +1. And that looks okay. Oh, and then Mark for Drawing was the other one I needed. So right click, make sure it's selected, go Mark for Drawing. All right, so I'm going to go ahead and save this one. This was called the number 2 head. And we'll go ahead and save. If we have, well, I already said that we didn't have anything in the whole wizard for the left hand. I could generate the diameters, but the call out might be a little confusing. So I am curious is if the thread, well, because it's picking an edge for the thread location, we pretty much have to generate the geometry. So that being the case, Let's see, do I want that? Well, we're not really going to go get a 1/875 drill point. I don't know that my boring bar is going to be perfect. What do we have for a depth for that call out? Didn't really. Other than this was about 3 inches and we have enough depth there. Alright, so if I grab the calculator, 1 divided by 5 would be 200 thousandths. So it's going to be a pretty good sized thread. So we'll bring up the calculator so I don't have to do math in my head. 1 divided by 4.5, that was the 0.222. Alright. So a 2-inch, what are we going to be close to? Well, let's see if we can get the whole wizard and find something that's close to that. So a standard drilled hole, fancy inch, ANSI drill sizes. Well, we're topping out at 1 inch, so that's not a big help. And so this would have to either be bored or milled as part of, and there is a way to go into the Hole Wizard database to tell us to get to a larger size. I could do the cut revolve and get the drill point. I don't know that the drill point is that critical. And more than likely, we're going to be cutting this. We're going to have to cut this on a lathe, or I really don't know about a die that big, so, or a tap that big. So front sketch. Well, let's see what it looks like. All right, so this time I'm just going to draw. We'll leave the 118-degree drill point. It will probably only be a truncated 1 inch to start it. But let's just say that I need the drill point, and I'm going to include it. All right, so between those, I'm going to go with, let's see, 118 would be 59 as the half angle. I need 3 inches. That's going to be interesting. And since I didn't include a center line, the minor diameter is going to be 2 minus, now let's go ahead and include the, we're going to have a lot of 2's here, 2 minus 0.222, and divide all of that by 2. So 889. All right, so advantage of the center line is, well, I'll have to select here, but it would be a little easier to calculate that. We're going to do a revolve cut. And then the axis of revolution is the inside line. If that was the center line, then it would have gone ahead and picked it. All right, let's see what we can get with the thread now. We have the geometry. That little bit of flicker makes me think I should have saved. All right, so blinding condition, 3 inches. That's gonna probably take it right to the edge. Cutting the thread, left-handed thread. Let's go ahead and trim it with the start face. And that should be that face. And then we'll go ahead and accept and see what we get. Only unable to cut thread on cylindrical surface, use extrude thread instead. Okay, let's see what happens if we turn the trim with surface off. And we offset this out into the geometry, reverse 1/4 of an inch. So why doesn't it like that cylindrical face as an interior cut? So other than it terminating into, so let's see if we can shorten that just a little bit, 2.75. And we'll switch over to a wireframe. No, it's stopping short. It's interesting. Alright, so the other one I did previously that I haven't done yet is let's go ahead and cut this with an extrude or a swept cut. So to do the swept cut, we're going to open up the sketch. I'm going to convert that geometry in as my base sketch. Hopefully my math is correct and not the problem with the thread. All right, so once I have the base, then we're going to accept. It's going to stay highlighted. So over in the feature, we'll go to a curve, and we're going to generate the helix. We're going to do height and pitch, so we'll call it 3 inches on the height. Pitch is 0.222. Start angle of 0 is good, and then we need to reverse the direction and tell it that it is a counterclockwise thread. All right, so counterclockwise is going to be the one that gives us that left hand. All right, so the curve's coming down. It looks like it terminates over on that side. If I did it right, I'll go back into the front. Curve comes down here. So on the front plane, we open up a sketch. Draw our 60-degree triangle, or thereabouts, pretty close. Put the line horizontal, make it for construction, and then go back into select. So I'm going to make the triangle thread just a little bit smaller, 221. Include the 60-degree angle. And we'll come back and pierce to the curve and go ahead and accept. Alright, so that overruns enough that we're assured, at least reasonably assured, that we're not going to have a weird shelf there at the start point. And then the swept cut for the 2. And we'll see where it terminates. Alright, we'll come back and hide the helix. Maybe. Alright, so I'm stuck in rollback. So let me escape and see if it'll clear from the rollback while my video card catches up. Alright, so hide the helix. Or did it? Nope. Make sure I didn't click through it already. Alright, so we have the fun with threads. Let's see if we can get a couple of radiuses in here without too much trouble. And call this one good. Alright, so the fillets are radius of 0.125, and we'll go ahead and accept and make sure to save. Alright, so I'm going to finish up this video here. We'll be on into the assembly next and see what that looks like.